Hey everyone, I realized there was a little bit of confusion with this central limit theorem homework, so I just wanted to do the first problem for you so you could see what's happening in this type of work. Um, so the central limit theorem basically gives us a way to take a normally distributed situation and apply it to a specific situation. If you read in the PowerPoint, what happens when we are using the central limit theorem is that we can say that the mean of a particular sample is equal to the population mean, and we can say that the standard deviation of that particular population is equal to the population standard deviation divided by the square root of the sample size. So in each scenario, you're asked to find a mean and a standard deviation, and you're going to use that information to do that. So the mean is really easy. You're going to say, okay, well, the mean for my population is going to be 4.59. I put it in without the dollar signs, and D2L took that just fine. So it should work for you too. For the standard deviation, I need to take the population standard deviation of 0.90 and divide that by the square root of the sample size. So although I can't really show this effectively on the screen, what I did is I put into my calculator 0.90. I'm actually doing it again as I'm talking to you. So 0.90, and then I'm dividing that by the square root of 16, which that's an easy one, that's 4. So I'm just dividing that by 4, and what I get is 0.225. So that's my standard deviation for this gas problem. So mean and standard deviation. For the mean, we just use the population mean exactly as it is. Standard deviation, for the sample, we use the population standard deviation, that's given, divided by the square root of our given sample size. And that's how we get the standard deviation for our sample. For the probability, I think what's confusing about this is it's pulling you out of just specifically talking about the central limit theorem for a moment and going back to what you did in module 2 with the probabilities and the normal distribution. So what we're actually doing is the same type of stuff that you did in module 2 when you had to find probabilities given a normally distributed population. So what I'm going to do is I'm going to say, oh, okay, I have this particular mean and standard deviation. I'm going to go into Minitab, and I'm going to go to Graph, and I'm going to go to Probability Distribution Plot, View Probability. Okay, I'm on the normal distribution. I meant to erase that, I didn't. These are actually the values that I already put in. This is the mean, 4.59, and the standard deviation, 0.225, that we just figured out. Then I'm going to go into options, and for the very first thing that we're asked to do in this scenario, it says, what's the probability that the 16 stations will have an average price less than $4.60? So what I did is I chose to do a left-tailed distribution for everything that's less than this specific x value, 4.60. Then I clicked OK, click OK again, and now I have my distribution plot. The probability, remember, is the size of the red shaded area. So my probability here is 0.5177, or it's not quite 52% chance that the station would have a gas price less than that mean, or that the 16 stations will have an average price less than that. So I'm going to put in 0.5177. And those are the correct answers for these 3 problems. The rest are similar. So if you're struggling with these situations where you have to find the probability, go back to the PowerPoints and the notes that you had from Module 2 for finding probability with the normal distribution, and that should help you out. All right, have fun.